Welcome back to my channel Chiro's Aspirations. Today I am back with another amazing and fantastic concept. As I am doing the CBSE 10th standard mathematics chapter by chapter concepts, so we are on that process, and also I will be doing the natural phenomena mathematics in everyday life. I am doing that also. Already I have covered 3 concepts related to that. And in today's concept, we are going to see what is rational number and to prove irrationality of numbers. So this is the first chapter of CBSE 10th standards real numbers. Past 4 to 5 videos I have done on this chapter, and this is the last topic I am going to do on this chapter, that is the rational numbers and to prove irrationality of the numbers. And the people who are new to my channel, hi, this is Chiranjeevi, motivational speaker and a maths trainer. So I've been doing all these videos. I also have another channel like Motivations by Chill. I'm an internationally certified soft skills trainer and an internationally certified NLP practitioner. So I have that channel also. If you need motivations, any type of things like communication skills, interpersonal skills, etc., you can subscribe that channel also. Please click the I button and subscribe the channel, and you'll have amazing videos. Coming back to this video, today we are going to see what is rational number and irrational number. Already the basic of this real numbers like rational, irrational, all the types of numbers I have made in the previous videos. You can click the I button and go to that video also. You can see what all the basic things. Anyway, today we are going to discuss about rational numbers and irrationality. What is this rational number? Any number which is in the form of P by Q, alright? Any number which is in the form of P by Q where Q is not equal to 0. The denominator should not be equal to 0. So that is rational number. So here the question arises in many previous question paper we see. Determine or prove the number which are in the form of P by Q without actual division method. Without actual dividing, we should tell that the number is terminating or non-terminating. You people know that what is terminating and non-terminating. Whenever we divide a number which stops at some point and the remainder is 0, that becomes terminating decimal. Whereas when we start dividing, it continuously goes and the remainder does not become 0 and the quotient continuously increases. So there where we tell that it is non-terminating and repeating, or non-terminating and not repeating. And here by certain methods we are going to find without actual dividing. For example, if we divide 7 by 5, we have 7 and 5, 5 ones are 5 and 2 remainder. Again we keep a decimal point and add 0 here, so 5 fours are 20. So here it was a terminating decimal, the remainder we got as 0, just 1.4. This is the quotient. But whereas in some cases what happens, it continuously increases, the numbers go on, the division goes like that, and therefore it is non-terminating decimal. We are not going to do this actual division. Without doing this division, we are going to find out whether the fraction or whether the decimal or a number is terminating or non-terminating decimal. So for this we have certain formulas. So if you remember that, it's enough. Now any number we are going to divide. For example, so if I take some 24 like this, I am going to divide that. So 2 12s are 24, again 2 6 are 12, again 2 3s are 6, again 3 1s are 3. If you find all these numbers, these are prime numbers, right? 2, 2, 2 and 3, yes. So any number can be expressed by the product of its prime numbers. So we can find these numbers with the prime numbers when we divide this number. This is obviously, we know that we have did in the previous videos also, that is the fundamental theorem of arithmetic. So what does this fundamental theorem of arithmetic tells that any number can be divided into multiple numbers of its prime. Finally it ends up in the prime numbers. So these are prime numbers. So this same fundamental theorem of arithmetic, we are going to use it for deriving certain formula, so that it will be very easy. Without actual dividing the number, we are going to tell whether it is terminating or non-terminating. So now what we are going to do here, any number which is in the form of P by Q, that is the condition, any number which is in the form of p by q, where q is not equal to 0, and this q should be in the form of 2 to the power of m into 5 to the power of n. Observe carefully. So this p by q, it is a rational number. So this denominator q, it should be in the form of 2 to the power of m into 5 to the power of n. If this is in this form, then we are going to tell that it is terminating. Whenever q is not equal to or is not in the form of 2 to the power of m into 5 to the power of n, then it is non-terminating and repeating. I hope you people are following. See, whenever p by q, where q is not equal to 0, this is the condition. And if the denominator q is in the form of 2 to the power of m into 5 to the power of n, that is terminating decimal. And if the denominator is not in the form of 2 to the power of m into 5 to the power of n, that is non-terminating and repeating. So simple it is. If we observe the denominator and divide that into prime factors, then we will be getting 2 and 5 or such type of numbers. So what happens if we observe the denominator, if this is in the form 2 to the power of m into 5 to the power of n, then directly you can come to a conclusion that it is terminating decimal. Whereas if it is not in the form of 2 to the power of m or into 2 to the power of m into 5 to the power of n, then that is non-terminating and repeating decimal. Let's do a problem and verify the relation. So I can take some number like 33 by 50. So here this 33 by 50, this is in the form of p by q, where q is not equal to 0, the first condition satisfied. Now what I am going to do, I am going to check whether q is in the form of 2 to the power of m into 5 to the power of n or not. Just I am going to take q, that is the denominator, 50. Now I am going to divide this. It is 2 25s are 50 and 5 5s are 25, 5 1s are 5. Now I used fundamental theorem of arithmetic and I divided 50. I got all the prime numbers. So 50 or q is equal to 50 is equal to 2 into 5 square. Did you observe what form we got? This is nothing but in the form of 2 to the power of m into 5 to the power of n, right? So where m takes the value 1 and n takes the value 2. Here m is equal to 1 and n is equal to 2, isn't it? So we got this form. Obviously this number is terminating decimal. Without actual dividing 33 by 50, we are going to conclude that this is a terminating decimal by just observing the denominator and dividing it into its prime factors and observing that it is in the form of 2 to the power of m or 5 to the power of n. This form if it is, then it is terminating decimal. So let me take some other example like 17 by 90. So here this is also p by q and where q is not equal to 0. The first condition satisfied. Now what I am going to do, the denominator q is equal to 90 I am going to take. Again I am going to divide 90. So 2 into 45 is 90. So 5 into 9 is 45. And 3 into 3 is 9. Again 3 ones are 3. So many prime factors I got by applying the fundamental theorem of arithmetic. Now 90 can be written as 2 into 3 square into 5 to the power of 1. So if you observe here, what happened? Always we should get the prime factorization form as 2 to the power of m into 5 to the power of n. Then that is terminating. Here we got 2 to the power of 1 into 3 square into 5 to the power of 1. So here the 3 is extra. Hence we can conclude directly telling that it is non-terminating and repeating. So it is not terminating. I hope you people are enjoying and understanding this. So this way we can conclude that without actual dividing whether the number is terminating or non-terminating and repeating. Now the second concept we are going to prove an irrational number. We all know that irrational numbers are the numbers which cannot be expressed in the form of p by q. So here, irrational numbers proving, we have certain things. For example, root 2 is irrational, root 5 is irrational, pi is irrational, and etc. It goes on like that. So root 2, root 5, pi are all irrational numbers. We need to prove this numbers as irrational. Before going to proving this number as irrational, we are going to a small theorem. Let's see. We all know that the fundamental theorem of arithmetic states that a particular number can be divided into multiple prime factors. So here what I am going to do, the theorem is, if p is a prime number, if p is a prime number, then a is an integer. So if p divides a square, then p divides a. This is the theorem. Now, to prove this theorem, we know that p is a prime number, and if p divides a square, we need to prove that p also divides a. So let a be an integer. Let a be an integer. I am going to take a is equal to, by the fundamental theorem of arithmetic, we know that whenever a number divides, for example any number we are going to divide, so we'll be getting its respective prime factors, right? So these are the prime factors. Similarly, if we consider a as some integer, we'll be getting prime factors like this, p1, p2, p3 and so on to pn, right? I hope you people are following and understanding. So likewise, any number if we divide, we'll be getting prime factors. We have got a is equal to p1, p2, p3 and so on to pn. Now the condition they have given, p divides a square. So what I am going to do, I am just going to square this a square. We know that a is equal to p1, p2, p3 and so on to pn. A square is nothing but a into a, right? So that's nothing but a is nothing but p1, p2, p3 and so on to pn into this a. Again the a I am going to write, that is p1 into p2 into p3 and so on to pn. Now just the a square, I have split that and I have substituted this a what we have taken, the product of primes. So here again a square is equal to p1 into p1 is p1 square, right? We will be getting like this, p1 square, p2 square, p3 square and so on to pn square. Now if you observe carefully, the condition already they have given that if p divides a square, now p is dividing a square, hence this p divides a also. So here if you observe, a square is equal to p1 square, p2 square, p3 square and so on to pn square. By the given data we know that p divides a square, right? So p divides a square. That results in, we have a square as p1 square, p2 square, p3 square and so on to pn square. This is a square, right? That divides p, isn't it? So p is dividing a square, and a square we have p1 square, p2 square, p3 square. We know that we got this from fundamental theorem of arithmetic, and this one we have, this divides p. Now let me take some examples so that the theorem will be more clear. So let me take a as, this a as 21. So a square will be 441. Now what are the factors of 441? We'll be getting like 3 into 3 into 7 into 7. These are the factors of 441, right? Now I am going to take any number, prime number. Here it tells that we have p as a prime number and p is dividing a square. So here any prime number, we got all the prime numbers here, the factors of 441, and I have considered a as 21. A square is 41. And any one number I am going to consider here, either 7 or 3. So now if 447 divides 441, let's say if 7 divides 441, then 7 divides this also, right? Now we saw taking the number as an example. So here we have considered a as 21 and a square as 441. What happens? So we have all the prime factors here, prime numbers, Okay. Now, as per the given, we have a square. The prime number divides a. So here we have taken the prime plus 7. If 7 divides 441, then the 441 must contain 7 square term. As a result, what happens? A square is equal to 441 and a square term as 7 square term. I hope you people are following this. A square term as 7 square term. As a result, A has 7 term. Similarly, what's happening here? If P divides A square contains P square term. Here we can see all the square terms here. So if P divides A square, so A square contains P square term. Since P divides A square and A square contains P square term, A contains P term. As a result, we are going to write P divides A. This is the proof. I hope it was very simple and amazing proof. Now, let me go to an example. Likewise, let us take like prove that root 5 is irrational. So this is the question. So we need to prove that root 5 is irrational. The first step what we are going to do is, let's assume that root 5 is rational. For proving sake, what we are going to do, the first step, we are assuming that root 5 is rational. So let root 5 be rational. So whenever it is rational, then it will be in the P by Q form, right? So here let me consider A by B. So root 5 is equal to A by B. Now what we are going to do, we are going to squaring on both sides. I am going to square on both sides. So I will be getting root 5 square, that is equal to A by B whole square. That is equal to, that implies, so root 5 square is nothing but 5, that is equal to, this becomes A square by B square. Now I am going to take this one, B square is equal to A square by 5. So just I have interchanged this. So B square is equal to A square by 5. What is happening here? Here 5 divides A square, right? 5 is dividing A square. As per the theorem previously we proved, if 5 divides A square, so 5 divides A also, right? Okay? If 5 divides A square, also 5 divides A because of theorem. So if 5 divides A, we are going to get some number, right? Some integer. So if 5 divides this A, we are going to get some number. That one I am going to take it as C. Okay? So that implies A is equal to 5C. If I take this equation as first equation, I am going to substitute this A value, okay? Substitute A in equation 1. I am going to substitute this equation, this A value in equation 1. What happens? It becomes 5 is equal to 25 or 5C square by B square. So that is equal to, what happens? That implies 5 is equal to 25C square by B square. Isn't it? Yes. Now what happens? I am going to take this B square this side. So it becomes B square is equal to 25C square by 5. This 5, I am just replacing it, becomes 5. So 5 ones are 5 5s are 25. So therefore, B square will be equal to 5C square. We got B square is equal to 5C square. The same thing I am going to do. What I am going to do is, I am going to take here C square is equal to B square by 5. So from here, I am going to take that, just I am bringing this 5 down. So according to the theorem, if you know that, if 5 divides B square, 5 divides B also, right? So here we have given A by 5 is equal to C, here B by 5 will be giving D. So B is equal to 5D. We got another thing. If you observe clearly, A is equal to 5C, and b is equal to 5d. In the two things, 5 is same, right? Initially what condition we took? We took let root 5 will be rational number such a way that these two a and b are co-primes, which means they doesn't have any highest common factor. Whereas coming to this condition, we got some factor here which divides. So this proves that it is a contradict for the sentence or for the assumption what we have taken initially. So we are going to write this, let me take like this. Since we arrived getting factors which contradicts our assumption that root 5 is rational, therefore root 5 is irrational. Hence we have proved root 5 is irrational. Initially we considered as rational number, but we arrived at getting factors, so that's not possible. So it contradicts the assumption what we have taken. Hence root 5 is irrational. We can take the same procedure for taking anything and proving like root 2, all those numbers. Or you can take some abstract value like p also, you will be getting the same thing. So the same procedures. So if you take any irrational number, first you consider an you take assumption that it is a rational number, and same procedures finally you arrive at it's an irrational number. I hope this was an amazing and fantastic video. Now we have completed the chapter real numbers, the first chapter of CBSE 10th. In the next video I will be coming up with a very interesting topic, that is polynomials. So this real numbers chapter, I have done previous topics. You can go to the description, click the link, and you can go to that videos also. And every week I will be coming up with the natural concept of mathematics in our day-to-day life, what we see, and in nature, all those things. I am doing already 3 videos I have done, and I will be doing that also. So if you like this video, like it, comment and share. Don't forget to subscribe my channel. We'll have a great journey of mathematics and science. And you feel any concept is critical or any concept is tough, you can comment, and any doubts you have, you can comment in the comment section, and I'll be coming up with that video explaining it. So I hope it's very enjoyable and understanding. Always be mathematically inclined and be curious to know the things. Bye. Take care.